Welcome to a short introduction of the Accusizer single particle optical sizing system, which is both a liquid particle counter and a sophisticated particle size analyzer. This diagram shows the basic technology behind light obscuration or light extinction sensors. As a particle passes through a constricted flow in the measurement zone, the particle interacts with light, generates a pulse. This is fed through a pulse height analyzer, which then uses a calibration curve to convert each pulse into a particle size. And one at a time, we build the particle size distribution and also count the particles and report results in particle per milliliter. This diagram of light extinction technology is not to scale, but as particles pass through this narrow ribbon of light, they interact with the light, not just through casting a shadow, as obscuration might sound like, but any light scattering that diminishes the light, the initial light source, as it hits this extinction detector. So this generates what we could think of as a negative pulse, and this pulse then can be converted to a particle size using the calibration curve. And the typical calibration curve of a pure light extinction sensor, as shown here, is good down to about 1.5 microns. But in order to improve the dynamic range, Particle Sizing Systems has created the single particle optical sizing sensor, which has both an extinction sensor plus a scattering sensor. So now we're actually going to use a detector to look at this additional light scattering, which we could think of as a positive pulse. We take these two pulses, the extinction and the scattering, combine them, and then take this combined pulse and use this pulse to convert it to the size distribution. This is the calibration curve for the combination light extinction and scattering sensor. This is for the LE400 sensor, which has a dynamic range of 0.5 to 400 microns. The upper concentration limit we can work out with this sensor is in the range of 9,000 particles per ml, and the reason there is an upper concentration limit, as shown in the diagram here in the lower right, is we can only have one particle at a time passing through the measurement zone. To the right here, where we see two particles passing through at the same time, we would erroneously report this as one particle of a larger size. So that is why we have a concentration limit, and there is a concentration limit to each of the sensors we will talk about today. This is just showing the accuracy and the high resolution capabilities of this technique. This is showing 11 different samples, 11 different standards run at the same time across the dynamic range shown here. And if we actually blew up this plot, we could show the peaks at 100 to 200 microns. And there's really no other technique that has a combination of this broad dynamic range, high accuracy, and high resolution to be able to pick out all 11 peaks like this. As we wanted to improve the sensitivity to smaller particles, the change that was made is that we started focusing the laser beam. So as we focus the laser beam to the center of the measurement zone, we now have higher laser intensity, and we can measure smaller particles. The FX sensor is a focused extinction sensor, can measure from 0.65 up to about 20 microns. Since we're now focusing at the center of the measurement zone instead of illuminating the entire measurement zone, we actually have to collect many pulses from many particles and feed it through a deconvolution algorithm to build up the complete particle size distribution. In the lower right, we show a result running 4 different polystyrene latex standards across a range of 0.7 to 2 microns, showing we've retained the high resolution and accuracy technology of this technique, but have pushed this down to be able to measure to smaller particles. The next step to be able to move to smaller particles is again to use this focus light source, but now we'll use two sensors. The light obscuration sensor, which we actually take a mirror and bounce this over at 45 degrees to get the obscuration or extinction sensor. And here we have the light scattering sensor. By combining these two different sensors, and we actually have to work in both high and low gain modes because we have a certain saturation across the range of the pulse height analyzer. With these improvements in technology, we can now measure from 0.15 microns, which is 150 nanometers, up to a little over 10 microns. Still working at these high concentrations up in the range of over 1 million particles per ml. And in the lower right, we see us actually splitting 4 peaks from 0.3 to 0.6 microns. So high resolution, high accuracy, now being able to measure down to 150 nanometers. So that's the sensor technology. We have a pulse height analyzer, which acts as the counter. But we also have different samplers in order to transport the sample through the sensor and also, if required, to do automatic dilution. So the SIS sampler, which you see here, uses a syringe pump to draw the sample directly up through the sensor with no dilution. The A2000 system, shown here, can have a single pump where we draw the sample directly through the sensor. Or if we need to perform dilution, we can add an additional pump and draw a filtered diluent, mix that, and pass it through the sensor. The two systems here, the Accusizer AD and the Accusizer APS, have automatic dilution systems, either a single stage or multiple stage. Here we can take very highly concentrated samples, automatically dilute it into that optimum concentration range for the sensor, and perform the particle size analysis and get the particle count still accurately in particles per ml. This can be done in the laboratory, or in the lower right we show the online versions of the Accusizer that can work with any of these sensors and can be used in the process environment. One of the real strengths of single particle optical sizing is the ability to be able to measure a few large particles, the tails of distributions. I show one example here. This is actually a sample used in the microelectronics industry called a chemical mechanical polishing slurry. In the upper right, what we see is an Accusizer result. We took a 1.36 micron polystyrene latex standard. We took 3.4 microliters of the standard, spiked it into 250 mLs of the CMP slurry, and found this additional peak. We then took the same CMP slurry, measured it on a laser diffraction analyzer, and before we found the second peak, we had to spike 360 microliters into only 4.3 ml of the CMP slurry. So this turns out to prove that the Accusizer is over 600 times more sensitive to the presence of a few large particles than the laser diffraction technique, because this is an ensemble technique. So what does the Accusizer give us? Particle count, particle size, and the best sensitivity to a few large particles, which are sometimes the real problems that cause difficulties either in the quality of the product or in the process that we're monitoring. We can do this in the laboratory. This is showing the fluidics for an online system. We can use any of the sensors here. We have the sample come into the system. Since particle sizing systems has a lot of expertise in automatic dilution, we dilute this down to the proper concentration range. We bring it through the sensor and perform this measurement now very quickly. We probably can get updated results every minute. And this can give us alarms for out-of-spec conditions or allow us to divert a sample if we think there's a concern that this might cause difficulty in the microelectronics industry. So these techniques are available in the lab and also in process. So this is a liquid particle counter. It's a particle size analyzer. We can do this in the laboratory or online. This is the technique with the best sensitivity to pick up the tails, either on the large side or the small size. So it's a very wide dynamic range, high performance system. We have the fluidics to do auto dilution to most kinds of samples we interact. We can add auto samplers to the lab systems to work with very high sample loads. And we recommend you visit our website, pssnicomp.com, and if you go to the Documentation Download Center, you can download application notes that might be helpful to your specific industry. Thank you for attending.